Alright, section 2.2 is almost as short as 2.1, except the diagram we're talking about kind of a graphs and vectors and when and where. So we have a little vocab to catch up on with chapter 2.2. So we are going to use a coordinate system. Alright. And we have location of a 0 point and the direction we are traveling. So when we are, right now we are talking motion simply in two directions, down and back, or left and right, however you want to envision it. But essentially, if I start, this is my starting point, I travel 40 miles. I just traveled 40 miles. That's two-directional motion. Some vocab when we talk about our starting points, right? Origin, which is where you start from. Your time equals 0. So in the green drawing that I just drew, my big green dot right here is my origin. Position is separation between the object and the origin. So in the green diagram, I am 40 miles away from my origin. That's my position. Distance, how far I am from the origin. Position and distance are the same, except when you're graphing velocity or acceleration, it's going to change a little bit. But one word that we don't have in here that's important to have in here is displacement. And displacement is your distance from origin. So to kind of clean up these two ideas here, if we are driving in a car from Hayfield to Brownsdale, so I have Hayfield, I have Brownsdale, they're separated by 15 miles. All right. If I go from Hayfield to Brownsdale and back, the total distance I have covered is 30 miles. But my displacement, my distance from my origin, since I started in Hayfield and I finished in Hayfield, my displacement is 0. That's the difference between distance and displacement. Distance is really how far you've traveled. Displacement is where you are as it relates to the origin. So I kind of use the Hayfield-Brownsville example to kind of touch up on distance and displacement. Now, when we talk about vectors, we have vectors and we have scalars. And as I mentioned earlier, we're going to be dealing with just two dimension. Well, it's easy to work everything in two dimension. When we start getting to chapters 4 and 5, we're going to start throwing in 3 dimensions, and you're going to have to start figuring out angles. So we're kind of building from vectors and scalars. So vectors is a quantity with both size and direction. So quantity with both size and direction. For example, a force. Maybe I'm pulling at something at 35 newtons, 45 degrees north of west. That would be a vector. A scalar is a quantity that are just numbers without any direction. So just a number without any direction. For example, time doesn't really have a direction. You could use distance or temperature as well for scalars. One thing I want to point out, since we're starting to talk about velocity and speed, speed is a scalar. Speed does not tell you any direction. Velocity is going to tell you direction. So if I say I'm traveling 55 miles per hour, that is a scalar. If I say I'm traveling 55 miles per hour north, that is a vector. Vectors come into place particularly when you start adding multiple vectors together, which you'll do with forces. We don't necessarily do so much with speed, but we will a little bit with forces. So we have vectors and scalars. Now, the easy part is the resultant, which is the sum of two vectors. We always point from tail of the first vector to the tip of the last, so they're always touching. So if I have back to back, it's going to look like this to like this. So if we do look at an example of a vector, really easily, we have vector addition. We have 40 going, we'll say, to the right or to the east, and we have 30 going to the east. Our total sum, 70 to the east. Likewise, we could subtract. We could have 40 going to the right or to the east, and then we could have 30 coming back to the left or to the west, and our net vector is going to be 10 meters per second, or whatever unit we choose to be, to the east or the right. So very simple vector addition subtraction. Like I said, we will get more in depth with these when we start looking at three-dimensional motion and forces, but right now we're just dealing with the two-dimension.